In this short tutorial, let's learn TypeScript in React. Now, I'm not expecting you to already be an expert in TypeScript, but I highly recommend taking a look at the official TypeScript handbook, and you can find it by just typing in Google TypeScript handbook. And here it is going to teach you about the basics, everyday types, narrowing, functions, object types, etc. These are all great to know. Now, if you're somewhat a total beginner to TypeScript, I would still recommend knowing about types, whether that's in another language like Java or Rust or whatever, but this is not a tutorial for TypeScript from scratch. If you're interested in that, I actually have a whole course in TypeScript, and you can check it out in the description. Anyway, here I have already scaffolded a React project with TypeScript. Now for this I used Vite. So here if you come over to vite.js.dev, you'll find this getting started page, and then if you scroll down you'll have this section where it says scaffolding your first Vite project, and then you can just run the command. So you can use npm yarn pm. I wouldn't recommend npm. Please use yarn or pm, and then it is going to ask you for the framework. So you're going to choose React, and then it will ask you for the language. So for that, make sure to select TypeScript. Now, if you do not want to set everything from scratch, make sure to check the description. I have a link to the repository for this project, where it's already scaffolded with TypeScript, and it also has an ESLint configuration, so that we can also learn a few things about good coding practices. And I also have Prettier configured, and not only that, but it is also set up with Tailwind CSS. So we're also going to learn how to use Tailwind with React and well with TypeScript. So let's get started. So if you come here, we have this main file. We have React DOM, create root, and then we pass in document.getElementById. Now we know React is a SPA, which means a single page application. So everything that you see in React, at least if you're using it as a SPA, is rendered by JavaScript. So there's no HTML, everything is done via JSX, and ultimately all of these will be executed by your browser, and it is going to render the application. So for that, we actually have this index.html file, and as we can see, we have this div, and the ID is set to be root. So what this is going to do is get that element, it is going to target that element, and it is going to return, as we can see, an HTML element or null. And why null? Because, well, the element might not exist. However, we know the element does indeed exist. As we can see here, we have div ID root. So for that, if we were to remove this exclamation, as we can see, we get an error. We get argument of type HTML element or null is not assignable to parameter of type element or document fragment. And specifically, we're looking at type null is not assignable to type element. And that makes sense. It needs an element to render your React application. So in TypeScript, what you could do, since we're certain that this element is not null, right after invoking this, we can use the non-null assertion. And it is going to tell the TypeScript compiler, hey, this is not nullable. So it is going to get rid of the null for us. And in fact, if I were to extract this, so const root element is equal to document getElementById, and then we pass in root. As we can see, the type of this is HTML element or null. Now, if I use the non-null assertion operator, as we can see, we get an ESLint error, but I'll disable this for demonstration purposes. As we can see, it is no longer nullable. So in fact, we can replace this and we can say root element, and we can also get rid of this. Okay, so with this, let's move on to a component. How does a component look like? Well, we know components are functions. In this case, we're using the arrow function syntax, where we can bind a function to a variable. But for this, you could obviously use a function instead, a regular function. So up2, and then this is just going to return JSX. However, I have with ESLint a rule that enforces you to use the arrow syntax. Now these two are completely valid, but the reason I prefer this syntax instead is because you can assign the type like this. But why exactly do we have this FC type? And well, in fact, you can import this separately, so FC, and then you can just reference it directly. What is this? In what way does this represent a function component? Well, we know functions must return JSX, right? So in TypeScript, as you know, you can declare a function, so some component, and you could explicitly state that the return type is null. And so this component can only return null. But we know that we have the JSX syntax, but we also know that we can return a lot of things from a component. In fact, null is something that we can return from a function component. So that means that whatever this type is defining underneath includes null. That's why we can say return null, and as we can see, we get no errors whatsoever. So how can you achieve this behavior, at least somewhat? Well, for that you can explicitly type the component. So there are two ways to do that. One, you could use a type alias, but we'll see what that is in a moment. Or second of all, you can use this return type here, as you should know by now. So in this case, if we want to say that we can return, say, a div like this, and let me actually turn off this ESLint rule, as we can see, we get a TypeScript error. Type element is not assignable to null. So this JSX is actually of type element. So if we were to say this returns an element, now we get another error. Type React element is missing the following properties from type element, and it has attributes, class list, class name, client hide, and well, 164 more. But in fact, React gives you a utility type, React.ReactElement. And if I come here to this type, it is this crazy interface. But let's skip this, it isn't really relevant. You're not going to write types like that. But now what if we say return null? As we can see, type null is not assignable, so you can use a union. So you can say what I'm returning from this component is either a React element or null, and that way it accepts either. But now you're starting to use a lot of unions. What if React element doesn't encompass something that is valid JSX? You need to add the type here. So that's why we use React.FC, and that encompasses all of this for us. So we do not have to explicitly state all of these one by one. But how can we recreate our own FC type? Well, for that, since we're binding a function to a variable, that means that this variable holds a function. But how do you type functions in TypeScript? Well, for that, you could say function is equal to, and then you just say parentheses, so here are the arguments, and then this arrow syntax, and whatever comes after this is the return type of the function. So you can say this returns a string or null. That way you can create some arrow function, then you can give it this type, and this way TypeScript knows that this will result in either string or null, so the resulting value. So if I come here, as we can see, the type of resulting value is string or null. So now we're halfway there, right? But what are we returning exactly? Well, you could say a React.ReactElement or null, and then you can come here and say const some other component, and then you could say React function component, for example, not to be confused by the dot notation, because here we're referencing our own type. And then here, if I move this up and then say return some other component, as we can see, everything works just fine. So this is what the underlying FC type is doing. Obviously, it is way more nuanced. It has a lot of properties. It uses generics for the props, etc. But the general idea is this one. It is simply a variable that is a function, and that function returns a React element or null. But what about properties? What if we want to pass in properties? Well, for this, let's recreate the button element. Let's say we want to have a custom styled button. So you could say const button and then React.FC, and then here you're simply going to return a button. You could say type is equal to button and then click me, for example. Now we can render this button, and if I save this, then yarn dev, and then if I open this up, 5173, as we can see, we get this button. Now I'm using Tailwind, so it removed the classes, so I can come here and say class name, BG indigo or primary, then padding 2, and then rounded MD. And if I save this and then come back here, now the text is off. So text, primary, foreground, these are all variables declared in the globals or index.css file. So here we have the root. So we have background, we have the primary color, the secondary color, muted, etc. And these are all referenced in the tailwind.config.js file. So here we extend the colors. So I'm referencing these colors right here. That way it is consistent and I don't really need to come up with colors on the fly. Everything is via CSS variables, which is ideal, obviously. But now let's say we want to pass in props, we want to pass in the type, so the color can specify the type, the class name, or maybe we want to extend the class name and we want to pass in the props, so we do not have to say button, and if we want to change the label, we create another button and then reference it like so. Well, for that, we can pass in a generic to FC. So for that, it's convention to say props. And then you can say children, React dot, and then React node. Now React node represents null, represents a string, a number, a boolean, everything that is valid as a node in the DOM. So here in JSX, you can use a string as a component. You can use numbers, booleans, and even other React components. So by doing this, you can pass in props, and then you can destructure this, and then you can say children, and then you can escape this and pass in the children. So now, well, this is required, so we can say click me. And if I save this and then come back here, as we can see, everything is working as expected. But what are these props and how come this accepts a generic and maybe you don't know what a generic is? Well, these are the arguments of a function. So you can say function sum, and then a number, b number. Here you're specifying the parameters, the arguments that you can pass into this function and the respective types. So this is as if you were to say args, and you extract this into its own type alias, and then you can say this will be an object and you must pass in a and b, and these two must be of number. So you can say args, and then you pass in the type, and then you can say args.a plus args.b. This is exactly the same. So in React with components, the arguments of a component is actually the properties of a component. So yes, you could say that the properties of a component are the arguments of that component. Just as we're saying here with the sum function, these are the arguments of this function. So the same idea applies with components. Now the only difference is instead of you invoking a component like this, and then you can pass in the properties like this, as if you were invoking a traditional function, in the case of components, the arguments are passed like this. So you say type is equal to button, then class name, etc. Which you should obviously know if you have already worked with React. So that's why we specify the type here. Now you could get rid of this and then you could say this will be of type props. That's completely valid. But again, I like to use React.FC so that we can ensure the types and whatever we're returning from this component is valid as per what React expects. Now, what about this generic? How can we recreate this behavior? Well, it's actually pretty simple. Now, generics is a way for you to pass in whatever you want to a function and it could infer the type, or you can pass it explicitly. In this case, we're passing the type explicitly. But let's take a look at this. Let's say we want to say function, return me something. Now here, this function takes in a parameter. So you can say something, and the type of this could be any, for example. And well, this is going to return any, and then you say return something. Now let's say you have a number, so number is equal to 5, and then const result is equal to return me something, and then you pass in the number. Now you know that internally this function is returning you something. So if we take a look at result, you would expect the type of result to be number, but it isn't because the function is returning any. Now this is yelling at us because, well, I set a rule in ESLint, so you cannot use any. And why? Because you're now diving into JavaScript's world, and you always need type safety. So for this, you could say unknown, which is the type safe any. And this is simply telling TypeScript, hey, I have no idea what we're passing in. But since we have no idea what we're passing in, we need to treat it as we have no idea what it is, as opposed to any. Because if we have any here and then any here, you can say return something plus 5, and this is not going to throw you an error. This is completely valid. But if we say unknown, in this case, we now get an error. And why? Because the operand must be a number or string. And since this is unknown, it could be an object, an array, etc. So again, this is a way to tell TypeScript that we must treat it explicitly if we ever try to use this. So anytime you see any, well, at the very least, make sure to change it to unknown so that the TypeScript compiler will tell you that that's not valid, and you need to, in this case, enclose this if type of something is equal to number, then return something plus 5. And as we can see, it is now inferred as number, and so we can perform an arithmetic operation. So now let's go back to generics. We know that this returns any, but we know that this is in fact, well, returning a number because we're passing in a number. So how can we retain that information so we do not lose that type safety? Well, we can use generic, so you can say t, and then you can replace this with t. So we take in t and we return t. Now let's get rid of this for simplicity. Now by doing this, TypeScript can infer that since we're in fact passing in a number to return me something, in this case, well, 5, because this is a constant, and TypeScript knows that the value of number will never change, then it can narrow down the type even further to be 5. And so if we take a look at result, the type is 5. Now if we were to change this to say 5 plus 5, well, TypeScript cannot run the code pre-compilation to know what the result of this arithmetic operation is, and so it is just going to default back to number. And if we take a look at the result once again, it is now of number. But we can explicitly pass it in here, so we can say t is actually a string. Now we get a type error because, well, number is in fact of type number, and we're telling the function that it is going to accept a string. But this is just a way for us to be able to retain the type information, and this is incredibly useful. But let's go back to the function component type. How can we recreate this behavior now that we somewhat understand what generics are? Well, for that, we can say type my React.FC is equal to a function, and it takes in props, right? But the props are not required. So props unknown, and then you can say this is going to return a React.React node. So now we can come here and replace this with my React.FC. But well, it isn't generic, so we can get rid of this. Now we're getting an error here because it says property children does not exist on type unknown. If we were to change this to be any, the error went away. But the problem is now the caller has no idea what the properties this component is accepting because, well, it's any, and hence it accepts anything whatsoever. So for that, we can use a generic in type aliases. So we can say t or, well, props, and then we can change this to be p. And by doing this, now it requires this generic, so you can say props, and now this error went away. But now we're getting another error. Property children does not exist on type props or undefined. And that makes sense because we made properties to be possibly undefined. This is as if we were to say we can pass in either an object with children or we can pass in undefined. So for this, what we need to do is get rid of this. And as we can see, the error went away. So now we can set other attributes. So we can say class name, and this is not required. So this will default to either string or undefined. And then we get access to class name here. And then what we can do here is wrap this up and use this cn function utility, which is simply going to merge the tailwind classes. So now here, if I hit Control space, as we can see, we get a type safety. So we can say class name from here and then bg secondary. And if I save this and then come back here, as we can see, it is now secondary. But what if we want to pass in other properties? So not only class name, we want to pass in the type. So we can say type, this is not required, and it is either button or submit. And then we can provide a default value, as you know, if you know JavaScript, and then you can say type will be type. And now here you can say type is equal to submit, then you save this, come back here, inspect element, come here to this button, and as you can see, the type is successfully set as submit. Now here we're getting an error. The button type attribute must be specified by a static string or a trivial ternary expression, and this comes from the slint plugin from React. So this is a flaw in the slint plugin. So for this, we can just disable it and call it a day. Now, what if we want to add even more properties? So perhaps an onClick. Well, for that, you can say onClick. This is not required either. And it's just a function that must return void. In other words, it shouldn't return anything whatsoever. So now we can come here and say onClick, and then you can log or even alert and say clicked. And if I save this and then add it here, so onClick and then onClick is equal to a function, and then we invoke onClick. So here we use optional chaining since we know that onClick can be undefined. For this, you have two alternatives. You can say if onClick is different from undefined, then invoke onClick, or you can simplify this further and just say onClick, then question mark, that, and then the parentheses to invoke the function. And this is simply going to invoke it if it is not undefined, as simple as that. And now if I save this and then come back here, click here, as we can see, we get clicked. But what if we want to pass in the event? So if we take a look at this, we can see that the type is a mouse event handler, so of type T, and then an event handler of a mouse event. So as we can see, this starts becoming quite complex. Fortunately for this, all you need to do is say event, and then you can say React.mouseEvent. But we should be able to pass in the event, right? So for that, what we can do is say event React.mouseEvent. We pass in HTML button element so that it knows what properties to give to this event argument. And then we can simply remove this and say onClick. And the onClick property is actually accepting undefined. So that's why we can just pass it directly without saying something like different from undefined. If so, pass in onClick else null. Well, that's not the case here, so we can just say onClick. And then by doing this, we now get access to the event. So we can say event.preventDefault, and we can say event dot, and we get everything via the power of TypeScript. But this can become quite tedious and also error prone because the type, as we can see, actually receives button or submit or reset or well undefined. So here what you could do is just copy this, come here, paste it here, and then try to synchronize everything. But that's just unfeasible. What if you want to basically just create a wrapper for the button but styled, which is actually super common with Tailwind or CSS modules? Well, in that case, you're not going to type everything out, each property one by one. So for that, what you would use is actually the React.componentProps. So here you get access to all of the props, and then you can say without ref, and then you can pass in button. And by doing this, as we can see, we now get access to all of the available properties for the button element. So here we can just get rid of the onClick and even the children. Why? Because the children are actually included within the ComponentPropsWithoutRef. And so here we can say rest, and then we can get rid of this, say rest, and then we can just self-enclose the button. And if I save this, as we can see, everything is now cleaner. Now some of you might be wondering how come we are still passing the children if we're not defining the children explicitly here. Well, that is because the children are actually arguments of the function as well. So here we can say children is equal to rest.children. So this is just a shorthand. Obviously, you shouldn't use this syntax anywhere unless you're creating these styled wrappers. I wouldn't recommend coming here and then say children is equal to, and then you pass in something like click me as a string. Do not do that. That's horrible, but it's completely fine for these cases. So now let's try building a simple to-do application so that we can see how everything works together. So I'll get rid of this as well. And for now, let's render a div. Class name, let's say bg background, text foreground, then minimum height screen, and then let's add some padding, and then an h1, text for XL, font bold, and margin button 8, and then we can say to do application. Now let's initialize some state, so we can say const todos, set todos, and then we can say React.useState, and it will be a string as its initial state, or rather an array as its initial state. But well, here's a problem, and that is todos is inferred as never, because we're never setting the type. So as we can see here in useState, it accepts a generic, and this generic will be used for the initial state. So if I come here, as we can see, this one is the generic. So for that, we can pass it here explicitly, and we can say an array of strings. Now let's render the todos. For this, let's create components, atomic components, so that we can leverage TypeScript to its fullest. So for this, I'm going to create another component here under source. Let's call it components, and then we're going to create the to-do list.tsx file, and then export const to-do list React.FC, and then we can say type props is equal to, and then we can say todos is an array of strings, and then here we can say props is equal to, we get access to the to-do, so the arguments of the component, and then return an unordered list. Last name, we can say, let's recall we have margin button, so no need to add class here. And then we can say todos.map, we get access to each to-do and the index, and then we can render a list component. The key is the index, and then the value itself is the to-do. But in fact, we can change this up, so we can say keys index, and then class name is equal to flex, item center, justify between, bg card, then text card foreground, padding on x4, padding on y2, rounded medium, and then we can say margin button 2 for the list, or in fact, we can say here flex call gap 2, and that way we can get rid of this class. And then we can say span, we pass in the to-do, and then we can render a button. So here we can say bg destructive, text destructive foreground, padding on x2, padding on y1, rounded md, and then we can say on hover, bg destructive, and then 90. So a little bit of opacity, and then we can say here delete. Now we're missing the type, so type button. So with this, we can now come here to up, and then we can say to-do list, we import this, and then we can say to-dos to be these ones. And in fact, I'm not generally a fan of doing this, like wrapping this up. I would prefer to extract these into their own to-dos. So let's do that. Let's say export const to-do item React.FC props, and then the props will actually be the to-do, so just a string, and then we can say equal to a to-do, return a list item, and let's actually copy all of this, paste it here, no need to pass in the key, and we can copy this unordered list, we can paste it here, and then we can say todos.map, and then we pass in the to-do item. So no need to have this to-do list. So now with this, as we can see, we're just rendering them directly here, which looks way cleaner in my opinion, and less layers to worry about. So let's in fact rename this to be to-do item instead, and we can update this import. Let's now create the input, so the form. So to-do input.tsx, export const, to-do input, React.FC, and then here we can say input, and then set input, and then we can say is equal to React.useState, and it's just an empty string. Then we can return a form, and then we can create the function on submit. We can say event React.form event, then we just prevent default. We can for now say alert the input, and then we can say on submit is equal to, we just pass in the function. Last name we can say flex, margin top, or yeah, we could have margin top 4, and then an input type is equal to text, then value will be the input, so it is a controlled input. Then on change we get the event, and then we just say set input to be the event.target.value. Then we have the button, we can say bg primary, text primary foreground, padding on x4, padding on y2, and then rounded right MD. So we can now come here and bring the to-do input, and we render this. This actually has a margin button. So what we can do is get rid of the margin top, save this, come back here, and as we can see, we get the input with the add button. Now for good practices for accessibility, you would say label, and then you could say here to do, and then class name is equal to SR only. So it is not rendered, it's only for screen readers, and then we can say const input ID is equal to react.useID, and then we can say HTML4 input ID, and then the ID of the input to be input ID. So they are connected as per what is required for accessibility reasons. Now return type just void. And if I come back here, it is looking exactly the same, but there are no classes for this. So bg input, text foreground, then padding on x, we can say 4, padding on y2, rounded left medium, and then flex grow, or rather just grow, I believe. Yeah, flex grow 1. And then if I come here, as we can see, it is looking much better, but maybe no need to have the flex grow. But I guess this suffices for this example. Now let's add the logic for the add to do. As we can see, we do not get anything back. If I say ASD, we get this value back. So we can have some basic input validation. So we can say if input.trim or const value is equal to input.trim, if value is equal to an empty string, we can say alert, to do is required, and we return, so we bail out as soon as possible. Now let's actually, before proceeding with the actual logic for this, let's change this up. So let's come here, let's say types, and then we're going to create a type file. So todos.ts, export type to do, and this will be an object. It has an ID and then text, which is of string. And so we can come here and actually reference the to do type instead. That way it is an array of objects containing ID and text. So to visualize it, let's say ID, this will be 1, and then text to do one. And now we're getting a type error, so we must come here to the to do item. And then here we should change this to be to do. And this will be to do.text instead. And if I save this, come back here, as we can see, we get our first to do. But let's actually say margin top 4 or 8. And if I save this, everything is looking much better. But for better styles, flex call, and then gap 8. That way we can get rid of this and also of the margin top 8. And if I come here, everything is looking nice. Now for the logic for adding a to-do, there are two ways to do this. Either we can define the type props to be on create, so this will take in a to-do, or it could be just a string that's also valid. Then we can say props, and then we pass in or take in the onCreate function, and then we can say onCreate, and we pass in the value. And this way, we're passing in a function, so again, we pass in an argument which is of type string, and so when we invoke it, we're passing the inputted value but trimmed, and then here we can say onCreate, and then handle create. We can say handle create, we take in the value, so actually string, and then we can compute the ID like this, although obviously that's not ideal. Maybe we can use math.random instead, and then say toString. And this way, everything is now perfectly connected. And if I come here and say hello, click on add, we get hello. But since we're learning how to use TypeScript with React, how can we define the type for a setter? Let's say we want to pass in the setToDos. Well, one way to define that is say setToDos, then you take in a function, right? Because it's a function, you can pass in the new to-dos, and then it will be an array of to-dos, and then this is just going to return void, as simple as that. So now we can come here, we can say setToDos is equal to just setToDos, but that's not quite the type, and the reason is because let's say we want to use the previous setters. So setToDos, we take in the previous to-dos, and then we spread them over, create a new array, and then add the to-do. That's not possible because, well, as far as TypeScript is concerned, setToDos is just a function that takes in one argument. So for that, yeah, you could say, or this will be a function, we take in the previous to-dos, and then we return an array of to-do here, which corresponds with the type or the data type of the state. And now we get this behavior. But again, you're not going to write this up for every single state or setter that you're going to be passing in via props. And you could obviously forget about this. And so it is not entirely synchronized with what this is in reality. So for that, let's just copy this and paste it here. And as we can see, everything still works as expected. And well, this is just a generic, so we have a type, we say dispatch, so generic A, and then we pass in another generic, which is the setState action. And the setState action takes in the state type, which again is either the new state or a callback function that takes in a previous state, and you must return the new state. So this is just encompassed within this type, although for this, let's be honest, we're going to be using Copilot, so Copilot will fill in the blanks for us. We do not really have to memorize this. Long gone are the days where you had to recall every single thing. In our case, let's just keep the logic in the parent. So let's get rid of this and also of this prop. And let's add a void here since we're not returning anything. Now, what about deleting a to-do? Well, if I come here to the to-do item, we can say on delete, and then this will take in an ID, so type string, or in fact, what what I like to do is use indexed access so that it is all correctly synchronized. And what I mean by this is if we were to change the ID to be a number, it will be automatically reflected here. If we were to desynchronize it by saying string instead, now we need to come here and change this over to a number. So it is always a good idea to write your code in such way that it requires less mental overhead. So for this, always use indexed access. And then we take in the function, and then we can say onClick, we say onDelete, and we pass in the todo.id. And now we can come here, and let's remove this import, and then we can say onDelete. And then for this, we can just say set todos. We take in the previous todos and we just say where the todo ID is different from the past ID. And if I save this and then come back here, click on delete, as we can see, everything works just fine. And we also get validation. So as we can see, using TypeScript is quite basic. I mean, in the end, it's just typing everything. In this case, for useState, you can use the generics. For a function component, again, you can use this React.FC and then you pass in the generic, or you can just type the props right here. I prefer to be consistent, so I use this type annotation. And well, for anything else, well, that's pretty basic. That's just using TypeScript, because again, props is ultimately an object. So if you know TypeScript, you can type this out with ease. Now, in the off chance you do not know how to type something in particular, well, we have LLMs now. Maybe you have no idea how to pass in a generic to useState. Go ask ChatGPT. Anyway, let's check how we can use refs. So let's create a custom button component. So tsx export const button React.FC, and then we can say type props is equal to React.componentProps with, and in this case we say with ref, and then we pass in button. That way we get access to the ref property, and so we can say props, and then we can return the button element, and we take in the children and the props. However, we know this is not how we forward refs. We must use the React.forwardRef function. So for that, we can say is equal to React.forwardRef, and then this one accepts two generics. So it accepts the HTML button element, so it knows what it pertains to, and then the actual properties. And then, well, we just do this as you would. So display name button as you would with JavaScript. The only difference between JavaScript and TypeScript is this type annotation here. In JavaScript, you would omit this altogether. But in this case, we can say this, and then we can disable this. So as we can see, this is as simple as it gets. So it's just about defining the types and passing them through. So if you do not know what something accepts, one thing that helps a lot is looking at the declaration TypeScript files. So for example, if I come here, as we can see, we know that it accepts two generics. And in fact, the second one is not required because by default, it is going to be an empty object. And then it takes in a function. And this function is a forwardRef render function. And if we come here, it takes in properties, and the second argument is ref, which is exactly what we're doing here. Properties, so the first one, and then ref, which is the second argument of the callback. And you must return a React node. And then you can pass in the display name, default props, prop types, and you can start delving into each type. So as we can see, React node is this whole union. If I come here to the useState, again, takes in S, initial state is either S, or a function, a callback function, doesn't take in any arguments and returns or must return the state. And this will return a tuple, which is essentially a fixed size array where each element is known at compilation. So we have S, and then we have dispatch, setStateAction, and it passes in S. So it is retaining all of the type information via generics. So this is incredibly useful to know. Now this is using overloading. So as we can see, it has two different type annotations. One for when you pass in the initial state, and the other for when you do not pass in anything whatsoever. In the case that you do not pass in anything whatsoever, the generic will default to undefined, which makes sense, and then the return type is a tuple of S or undefined, which makes total sense, as if you do not initialize it, it will fall back to undefined as the initial state. So as you can see, as opposed to JavaScript, with TypeScript, you get a lot of information. You can see pretty much how everything works under the hood. Sure, you might not see the implementation details, but you know about the interfaces, the types, what it accepts, what it rejects, and then you can start delving into each type, and you can see how everything is typed. So now this wraps up the video. So again, if you're interested in learning all about TypeScript and becoming proficient on it, make sure to check out my course on Udemy. I hope you learned a lot from this video, and I'll see you in the next one. See ya.